Hey everybody, welcome. This video is going to be looking at the uniform distribution, and we're going to be doing a few calculations with this. So remember from last week, we looked at three different distributions: the rectangular one, the uniform one. This is where something has an equal chance of happening, such as rolling a die or picking a random number. We have the exponential distribution, which is more likely to happen in the early side and then it tapers down. Then we have a normal distribution. This would be useful for different heights and weights of humans in a room. So for the uniform distribution, it's going to come back to the fact that this is a rectangle. And that's going to be really helpful in calculating our probabilities. And we're going to calculate some probabilities again today. And remember, to do those, we just calculate the area of that rectangle. And we have some fancy notation here, but I don't want you to get confused by the fancy notation. It's not. It's nothing to be worried about. So what we're looking at here is a way to write our uniform distribution. We'll talk about that in a moment. Then we have a way to calculate the average, then a way to calculate the standard deviation. And remember in math class, we have a fancy way of writing average of mean. We use this mu, this Greek letter mu. And then for standard deviation, we have a fancy way of writing that too. We use this lowercase sigma. So keep those in mind. This is average, this is standard deviation. And I think the next page will make a little more sense about like where this average calculation comes from. This we're not going to explain where it comes from. We're just going to use it. Let's look at a concrete example. All right, so here we have our uniform distribution. And our distribution is going to go from 0 to 20. And we notice it's a rectangle, so it's a uniform one. And it needs to equal 1. So the area of this must equal 1. And if it goes from 0 to 20, to find out the height of it, we would just take this distance from 0 to 20, so 20, and we put that as a fraction, so 1 over 20. That's the height, because 1 over 20 times 20, base times height, right? That equals 1. So there we go. Every moment in here is a 1 in 20 chance of happening. So this is how we write it. X is represented, this little approximation sign is represented by U stands for a uniform distribution. And then the parentheses are going to mark our starting and end point. So 0 to 20. So a uniform distribution from 0 to 20. And if this was from 0 to 10, it wouldn't have a height of 1/20th, it would have a height of 1/10th. If it was from 0 to 5, it would have a height of 1/5. So to find the average of this uniform distribution, we want to think about this, as an example from 0 to 20, maybe this could be, how long it takes my kid to eat dinner. Maybe some days they eat dinner in no time, right? They refuse food. Other days they take 20 minutes, sometimes longer. So suppose it's somewhere in here. And the average then would be right down the middle. So to find the average, all you do is take the beginning and the end, and you add them together, divide by 2. Right? That's how we take the average of two numbers. Easy. So 10 is right down the middle. Standard deviation is much more complicated. For that, you have to follow this formula. We take the end point minus the beginning, so 20 minus 0, squared, divided by 12, and square root that. And our standard deviation here is 5.77. That's going to tell us the spread of our data and how far away we are from the average. That's going to be useful in future chapters, but right now, it's not very useful. But it will be good to know how to calculate that. All right, let's go to the second part of this example, and this lesson's almost done. To draw the graph of the distribution for the probability of x is less than 8. So to do that, we're looking at our normal distribution, not our normal distribution, our uniform distribution. And we want to find the probability x is less than 8. So I try to locate 8 on my graph. I made an ugly sketch of it here. Put the 8 a little bit too early, but you get the point. And I shaded in everything less than it. To calculate the area, the probability x is less than 8, we just calculate the area of this rectangle. And areas of rectangles are base times height. So base from 0 to 8, so 8 minus 0, 8, multiplied by 1/20th, so we get 8/20ths, or 0.4. So 40% of the time, my kid would eat dinner between 0 and 8 minutes. Yeah, makes about sense. Makes sense. And my kids are 1 and 3. The 1-year-old generally eats dinner in he's a mess. He eats, then runs around and eats on the go. But he eats pizza holding a whole piece of pizza, so that's delightful. Find the 75th percentile. So to find percentiles, what we're going to do, well, first of all, remember percentiles. 75th percentile means it's going to be higher than 75% of all the other data. So we're looking for something down here on the 75th percentile. 99th percentile would be way down here on the end. The first percentile would be down here. So to find the 75th percentile, we go ahead and just multiply our distance, so 20, by 0.75. So 15 is in the 75th percentile. And that's how we do percentiles. You just multiply that decimal by however long your rectangle is, and that's where you locate your percentile. All right, that's it for this.